This is MEI Statistics Minor, Bivariate Data 2, Correlation Coefficients. 2.3, Hypothesis Testing using the Product Moment Correlation Coefficient 2. As with all hypothesis tests, we need to write down our hypotheses before we complete the test. When we're doing a hypothesis test on the Product Moment Correlation Coefficient, our null hypothesis should always be as followed. Either H0, no correlation between whatever our first variable is and whatever our second variable is. An acceptable alternative is, we recall that the population product moment correlation coefficient has the Greek letter rho. So we can have that rho is equal to 0 because that value corresponds to no correlation. Our alternative hypothesis will depend on what we're testing for. If we're testing for any association, then we don't know which type of correlation we're testing for, positive or negative. So we will be performing a two-tailed test or a two-sided test. So our hypothesis will look like one of the following. Either some correlation between whatever the one variable is and whatever the second variable is, or rho is not equal to 0. If we're testing for positive correlation, that is a one-tailed test or one-sided test. Our alternative hypothesis will look like this. Positive correlation between whatever the first variable is and whatever the second variable is. Or alternatively, we want rho to be positive, rho greater than 0. Alternatively, if we're testing for negative correlation, it will be negative correlation between the first variable and the second variable, or rho is less than 0. The test statistic is the sample product moment correlation coefficient R, as calculated in video 2.1. The critical values can be found using one of the tables in the formula book. Just look out for product moment correlation coefficient and R. When you're using this table, you need to focus on whether you're using a one-tail or a two-tail test. You need to focus on what your significance level is, and you need to look at n, the size of the sample. Note that this table only contains positive values, positive correlation. So if you're doing a negative test, the values need to be negated. So example 1, we have a table containing height and mass of 8 male Year 13 students. Carry out a hypothesis test on Pearson's product moment correlation coefficient at the 5% level to investigate for correlation between height and mass. So, investigate for correlation. It hasn't told us in which direction, so that is any correlation. So it is a two-tailed test. We've been given the significance level here, and we should take note that in this case n is equal to 8. We start by defining our hypotheses. I'm going to use the symbolic notation, which is that rho is equal to 0, and as we're doing a two-tailed test, my alternative is that rho is not equal to 0. As I have raw data, I can find my test statistic R by simply popping that in my calculator, and I find that R is equal to 0.7880 to 4 decimal places. To find the critical value, we've already established that it is a two-tail test, so we will be looking exclusively in this row. We then find our correct significance level, which is 5%, and we go down this column until we find our sample size. Our sample size n is equal to 8, and so this is our critical value. Our critical value is 0.7067. That's approximately here. Since we're doing a two-tailed test, we're also going to have a critical value on the other side. This means that our insignificant region lies between these two values. And the significant or critical region is anything above this, or anything below this. Note that since R equals 0 is always the null hypothesis, this means that the insignificant range will always be this inner range that contains R equals 0. Our test statistic is 0.7880. That is going to put our test statistic right here. So that is in the critical region. So that is a significant result. So our critical value is equal to 0.7067. Referring to that diagram, 0.7880 is greater than that upper critical value. So it is significant, so we reject H0. And so we finish with our conclusion that there is significant evidence at the 5% level to suggest that there is correlation between the height and mass of male Year 13 students. We must always make sure that we include significant evidence or equivalent. We cannot be certain that that is the case, but there is evidence to suggest so. In our next video, we're going to be looking at the product moment correlation coefficient as an effect size.